Hello and welcome back to the channel. This is video 6 in our series on junior cycle electricity. You know the rules by now, the usual reminders. Please do close any social media tabs or any other tabs you got open on your computer because those are just going to distract you. And make sure you're doing the tasks and the questions because practice makes permanent, and that's what this channel is all about. It's giving you the opportunity to master the content. Before we begin, today we're going to be looking at how we measure potential difference and current in a circuit. Before we begin, we're going to begin with a quick recap of stuff that's important to make sure you've mastered before we begin today's lesson. So what I want you to do is I want you to get your practice copy or wherever you do your questions, and we're going to get out a pencil and a pen. The pencil is for particularly question number 3, where you're drawing a circuit. And if you make mistakes, it's much easier to fix it if it's in pencil. So what I want you to do is pause the video and try to do these 3 questions. Try your best. Okay, so if you've watched the previous videos, which you should have, these should be easy for you. Okay, so pause the video and do the questions now. All right, a reminder that you should only be listening to my voice if you have paused the video and done those questions. If you haven't, and you're just waiting for me to give you the answers, then you're really not going to learn very much and you're wasting your time. All right, what are the units for potential difference and current? Okay, so what we should have said here is for potential difference, the units are volts. So well done. If you wrote volts, you should have your red pen for correcting that. So that's a key thing, is that we don't just look at our answers, or we don't just do the questions and then fast forward and skip. We have to correct our answers because there's a lot of learning in correcting answers. Okay. So we've got volts for potential difference, and current we measure in amps, A-M-P-S. Or ampere is the full name, A-M-P-E or E. We shorten it to amps. All right, complete the sentences. So current is measured using an, okay, so that's going to be an ammeter, A-M-M. V-T-E-R, an ammeter. Well done, if you got that right. Potential difference is measured using then a voltmeter. A quick reminder that a lot of people make a very common mistake here. They call this an amp meter. Now, it's very easy to see why somebody might do that, because current is measured in amps. Technically, it's wrong. I mean, it's not the worst mistake you could ever make in the world, but just be aware that it is ammeter, 2 M's, not a P. Okay, so ammeter. When there is high resistance, the current is, so what happens if you make the resistance high? So you put more devices in the circuit, well, that's going to reduce the current in the circuit. So the current is either reduced or lower. Reduced slash low slash lower. Okay, something like that. All right, so when there is a high resistance, current is reduced. When there's a high potential difference, the current is, okay, so what you should have said there is increased or bigger, or high, increased, high slash bigger, because it's the potential difference that gives the coulombs of electricity the energy to move faster. So if they're moving faster, then the current is going to be higher. All right, well done if you got those right. You should have. I'm hoping that you did if you've been paying attention in the previous videos. So do make sure that you correct them. You make a point of actually correcting them. Okay. Draw a circuit with one cell, a resistor, and an LED. Okay, so again, this should be pretty easy if you've been paying attention. So one cell, so here is my cell. I've got a long terminal and a short terminal like this. All right, we then have a wire, and we've got a resistor. So here is my resistor. It's just a rectangle in the circuit like that, and an LED. So we've got a circle. For an LED, I've got the diode sign, so the triangle with the line or the terminal at the end of the point of the triangle like that. And then I have 2 arrows coming out at the top right hand corner. This shows me light, because this is a light emitting diode. So remember that this is a diode. It is a diode, and it's a light emitting diode. And then the wires connect back up like that. All right, so that is a circuit with one cell, with a resistor, and with an LED. So just check that, and if you don't have it right, fix it up for me now. Okay, so make sure you do fix it up before we move on. It is really good practice while we're learning all the different components, and we'll learn how to draw circuits. If we keep them labeled, it's really good practice. It's going to strengthen the names and the diagrams in our mind. So this is a cell, and this is one cell. So it's probably a good idea to label that as one cell. This is a resistor, and this here is an LED. And that's the first time we've probably used an LED in a circuit. So if you did get that right, well done. If you didn't, I mean, it's the first time using it. So, I mean, it's not that big of a deal. This is a second opportunity to learn how to draw it and how to learn how to draw it when we put it into a cell or into a circuit. Apologies. All right, good job. Time to move on. We're going to take a look at today's content, which is how do we measure potential difference in current? Now, we're going to be using our simulation again, and when I go to it, you will find the simulation linked in just below the video here. It's the same simulation we used the last day, and we are going to be using this circuit here. So this is just a single cell with 2 bulbs. I'm not going to get you to do that just yet. Before we do, what I would like you to do is I would like to take down this information here. This is a little like table or a recording sheet, I suppose. So if you've got your copy, we're going to just take down measuring current in the circuit and this number 1, 2, and 3, and then measuring potential difference in the circuit number 1, 2, and 3. And we're going to record our results or our data that we get from the simulation into this little table here. So take that down for me, pause the video and do that now. Okay, great. So you should only be watching the video now if you have taken that down and you're ready to go and do the simulation. So I'm just going to pause while I change the screen and get up the simulation. You should pause and you should open the simulation in a new tab now, please. Okay, so hopefully this is the screen that you're looking at. You have opened the simulation and you have the screen in front of you. All right, a couple of quick reminders. Here is a battery. So I'm taking that. If you want to get a battery, you just drag it out from the side here. Okay, so here is my battery. And for a socket, I need some wires. So I connect up the wires like this. It's very simple. And I just want to show you something just to remind us about potential difference in current. I'm just going to connect up the battery with 2 wires and we're going to watch what happens. Now, obviously, at the moment, there's no connection. We don't have a full loop. And we have these blue electrons here and they're not moving. So we still have these charged particles, which are coulombs of electrons inside the wire and the battery. But at the moment, they're not flowing. So we have no electric current because they are not flowing. So for a current, we need charged particles and they need to be able to flow. When it's not all connected up, they cannot flow. So there's nothing happening. Watch what happens if I just connect the 2 wires together. Whoa, what's going on? That's crazy. And look down here, it says animation speed limit reached. The simulation speed is reduced to less than 1% of normal. So that means really coulombs of electrons are going 100 times faster than this. So this is crazy fast. And watch what's happening here. The circuit is overheating. The battery could catch fire here. This is what we call a short circuit. So why is this going so fast? Why is it going crazy? Circuits don't normally do this. The reason is there's no resistance in the circuit. At the moment, we don't have any device there that's going to transfer the energy and provide a resistance. And if there's no resistance, then the coulombs of electrons can fly around the circuit so fast. So remember, the battery or the power supply is providing the energy, the voltage for the coulombs of electrons to move. And now they're moving just too fast. So watch what happens if I put a device in like a light bulb. So when I put a light bulb in, now what's happened? Well, now I've put a resistance in the circuit. And now the coulombs of electrons are going much, much slower. So it's all connected up and they're going much, much slower. And note the pattern. They're not just going slower in one place. They're going slower everywhere. So when I put this a resistance into the circuit, it slows the electrons down everywhere in the circuit. And the reason for this is they basically cannot be forced through the bulb too quickly. So this slows them down. They can't be forced through the bulb too quickly. So it takes their time to get through the bulb. And because of that, they all move much slower because, they're not going to move fast in one place and not be able to get through the bulb because then they just all back up here. And they don't do that. So the whole thing slows down in flow. If I cut this and I add in a second bulb, so I'm going to put in a second bulb over here. And now I am going to put in a second wire and connect them up. Watch what happens now to the current. Okay, so now the current has slowed down even more. I've got twice the resistance. So when I add in an extra bulb or an extra device, it slows down the current in the whole socket even more. So if I was measuring the amps of this, the amps would be lower now than when I had just one bulb. So can you predict what would happen if we put in 3 bulbs? Okay, well, let's check it. I'm going to cut it here and we're going to put in another bulb, a third bulb, and connect it up with a wire and so on. Okay, so now you can see they're going even slower again. So the current now is even slower. So the more resistance in the socket, the slower the current's going to be. Right, I'm just going to cut that again and cut that. I'm going to get rid of that. I think I can just throw that over there. Okay, and I'm going to get rid of this wire here. Right. All right, this was the socket you were asked to build. So what I want you to do is I want you to pause the video and I want you to build that socket for me. Do that now, please. Okay, so 1 cell and 2 bulbs, that's what you should have. Now, notice that the current is flowing this way around the socket, okay? The coulombs are flowing this way. So I would call this one here the first bulb, and I would call this one here on the right the second bulb. So the one on the left is the first bulb, the one on the right is the second bulb. Now, this here, over here, we have ammeters and voltmeters. The first thing we're going to do is we're going to drag out an ammeter. And as you can see, it has the word current here because an ammeter measures current. And it has a question mark in a box. Now that's where we could get a reading. Now at the moment, there's no reading because it's not connected to the socket. So how do we measure the current? Well, the answer to that is that we would cut the socket. We would need to break the socket. And we need to put the ammeter into the socket like this. Now it's not fully connected yet, so we're now going to get a wire and we are going to connect it up. So now we have a complete socket again, and we've got a reading where the bulbs are lit up, the current is flowing, and we've got a reading for current. Current is 0.45 amps. And this is the current before the first bulb. So this was the first bulb. This is the current when we measure it before the first bulb. So now what we have actually done, we've actually put the ammeter into the socket. The electrons have to flow through the ammeter like this. So it's part of the socket. It's like any other device that you put into the socket. All right, what I want you to do now is I want you to pause the video. I want you to go to your little table that you recorded and record the value that you get. You might not get 0.45. It depends how your battery is set up here. So you can change your battery's voltage and you can change your bulbs. Now, if you just set it the same, just open it up and you didn't change any of that, then I'm guessing you'll have the same as mine. Okay, but what I want you to do is I want you to record in your the first reading, 0.45 amps is the current before the first bulb. What I want you to do then is I want you to pause the video and I want you to take the other 2 readings for current. Current after the second bulb and then current in between the 2 bulbs. So you should have measured the current before the first bulb, the current after the second bulb, and the current between the 2 bulbs. All right, so pause the video and do that now. Okay, great. So hopefully you have measured the 3 readings for current and you have recorded them and written them down. So this is what you should have done. So how you do this, by the way, is sorry if I didn't make this clear, if you click on it, you get the little bin and that means you can cut it out. Okay. And then you just drag it over again. Or if it's in the socket and you want to cut it out, if you cut on the link, you get the scissors and you cut it out and you can use it again like that. Okay. So if you didn't know that, please do it now and measure the other 2 readings for current. Okay, so you should only be watching the video if you've measured 3 readings for current. So you should have measured it before the first bulb, and then the next reading was after the second bulb. So let's check after the second bulb. So I'm going to cut the joint here like this, No, not that one. Yeah, so we're going after the second bulb, which is over here. This is the second bulb, so we're going after the second bulb. So I'm going to put the ammeter into the socket after the second bulb. I can use another wire to hook them up. So from the second bulb to the ammeter. Okay. Oh, look, same reading. And that makes sense because I can look physically and see that the coulombs of electrons are moving the same speed everywhere in the socket. So the current is the same before the first bulb and after the second bulb. It hasn't changed. So it doesn't matter where in the socket I measure it, the current is the same. All right, so you should have recorded 0.45 for the second one or whatever you got. It should have been the same as the current before the first bulb. All right, now for the third reading, you're going to measure the current between the two bulbs. So I'm just going to cut this out, that, drag that over there, and then hook them up like that. Now I need to cut that link there. Okay, so between the two bulbs would be in here. I've got my ammeter and it's connected between the two bulbs. Current is flowing again. Oh, look, like I said, current is the same everywhere in the socket. So hopefully you got the same current everywhere in the socket. I'm just going to pause the video while I go back to my OneNote screen. Okay, all right, so this is what we should have had here. This was my readings. I had 0.45 amps like that. So I'll make sure to put in the A to show the unit amps. The current after the second bulb, well, it was the same. It was 0.45 amps. And the current between the two bulbs, well, it was the same. It was 0.45 amps. So what can I say? I can say about this, the current is the same everywhere in the socket. So unless I change something, like if I add more bulbs in, that would change the current everywhere in the socket. If I change the potential difference, so if I added an extra cell, that would push the electrons quicker, so that would change the current. But if I don't change anything, if I have the same amount of power, so the same amount of batteries, and have the same resistance, then the current is the same no matter where I measure it in the cell. A quick note, just how we would show this, guys, in a circuit diagram. We would have our cell, and then if I wanted to draw the current being measured before the first cell, like I did before, like we did there at the number 1 there, I would put the ammeter into the socket here, like this, A, and then I would show, here's my first bulb, here's my second bulb, and then it's connected back around. So that's how I would draw number 1. If it was number 2, I would, oh, it's a bit much anyway. I would have a complete circuit that side, and I would have the ammeter over here, like this. Again, it's in the socket. It's like any other device. You just put it into the socket like any other device. And then for number 3, obviously, I would have to put it in between the two bulbs. So I might get rid of that wire like this. And we could say, okay, so we've got that ammeter here. And it's connected up like that. And that's not great. Wouldn't really. I prefer if the A was in between the two X's, but I'm too lazy to rub it out like that. I just want to show you how we're supposed to draw it. Okay. We're going to go back to the simulation now. All right, so I'm just pausing the video again for a second. All right. Okay, I just really want to highlight the point that the current stays the same unless it was 0.45 everywhere, unless we put in another resistor. So here I'm putting in a third bulb, and now what's happening to the current? Now the current is lower. Now the current is 0.3 amps. So I've reduced the current in the whole socket because I've added an extra resistance. I can also, guys, I'm going to change the voltage of the battery. I'm going to put more volts in here. Watch what happens to the current. Now we're going to take a stronger look at this relationship in a future video. But as you can see, if I increase the voltage, I increase the current. Okay. Now, right, so I'm just going to start again. So blank page, I did that by pressing this little replay arrow down in the bottom right corner. You can do the same. Right, what we're going to do is we're going to build the same circuit again. We've got our battery, we've got our wire like this. We've got two bulbs. So there's bulb number 1, wire. This is bulb number 2. And here's my last wire. Okay. Now, so we've got a circuit again. This time, we're going to measure the voltage or the potential difference. We're going to measure the potential difference. We measure the potential difference, as we saw in the questions earlier. We measure that with a voltmeter. So here, voltmeter, I'm going to drag this out here like this. You'll notice the voltmeter looks a little bit different. It's got these 2 wires here. And that's because a voltmeter doesn't connect in the same way the ammeter does. The ammeter became part of the circuit. We hooked it up as if it was part of the circuit. We just put it in like a normal device. The voltmeter works by measuring the potential difference, and we measure it across a device. So I think the first thing that you have to measure is the potential difference across a cell. That's what your number 1 says for measuring potential difference. We do this by taking these guys, these little terminal wires. Okay, we take these and we attach them either side of a device. So the first one you have to do is the cell. So I'll show you how to do this. You take the black terminal and you can connect it to the left-hand side of the device. Now, you can really connect it here at the edge of the battery, or you can connect it in the wire at the left-hand side of this device. It's probably a bit more accurate to actually connect it to the left-hand side of the device like this. Then we take the red wire. We still have no potential difference reading yet, by the way, because we haven't connected it to the other side of the device. So what we're doing is we're measuring the difference in energy between the 2 sides of the device. Okay, now we've connected it up, and as you can see, I have a reading. The reading across the battery, the potential difference across the battery is 9 volts. That makes sense. This is a 9-volt battery. So 9 volts of potential difference is transferred to the coulombs of electrons across this device, the battery. 9 volts is the potential difference here. So you should record that. Okay. Right, the next task is to measure the potential difference across each bulb individually. And then number 3, the potential difference across both bulbs together. Now, if you think you know how to do that, you go ahead and do it now. If you need a little bit of help, you're not sure what I'm on about, then you can wait for me. Okay, so I'm just going to give you a chance now. If you're comfortable and you think I can do this, pause the video and do it now. If not, then in a minute, in just a second, I'm going to go through how you would do this. So pause the video if you're confident, or even just have a play around and see if you can figure out what I mean. Okay. All right, so hopefully you did have a go at that. You paused the video and you had a go at it. If you didn't, well, I'm going to show you how we do that now. Okay, so I've got my voltmeter and it said to measure the potential difference across each bulb individually. So I'm going to do the first bulb first. So here I'm connecting the black terminal to the left-hand side of the bulb. I'm going to connect the red terminal to the right-hand side of the first bulb. Okay, so I have a reading here of 4.5 volts. So for bulb 1 or bulb A, the reading is 4.5 volts. Now, that's exactly half of the potential difference across the battery. So the battery was 9 volts. It was transferring 9 volts of energy to each coulomb of electrons. As the coulombs of electrons go through this first bulb, 4.5 volts is transferred, or 4.5 volts is the potential difference. So 4.5 volts across battery bulb A. What about bulb B? I'm guessing if you think about it, you can work out, well, what's it going to be across bulb B? If bulb A was 4.5 and that's exactly half of 9, well, bulb B, there you go. There's bulb B, 4.5 volts. So for number 2, you should have written down each bulb, or bulb A is 4.5 volts and bulb B is 4.5 volts. So each of those is 4.5 volts. So the potential difference being supplied by the battery is 9 volts, and then basically 4.5 volts are being used, I suppose, by each bulb, or the potential difference is dropping by 4.5 volts. So the potential difference is dropping by 4.5 volts across bulb A. So it was 9 after the battery, it's only 4.5 after bulb A, and then 4.5 is used by bulb B as well. So 4.5, in other words, the voltage here is split between the two bulbs. The voltage, or the potential difference, is split between the two bulbs. The last one asks you to measure the potential difference across both bulbs together. So I would do this by putting the left terminal on bulb A, the start of bulb B, A, and I will put the red terminal at the end of bulb B. And look now, there is the potential difference across the two bulbs together is 9 volts. So 9 volts is the potential difference across the two bulbs together, which is the same as the potential difference being supplied by the cell. So this is another way of saying that all the energy that's being transferred to the cell by the battery is being transferred to the surroundings by the two bulbs. Okay, now, just out of interest, let's put in a third bulb and see what happens. All right, so we're going to put in a third bulb and see what happens. Have a little guess, if you can think, before we start measuring, have a little prediction as to what you think the voltage in the bulb battery and then the voltage in each bulb is going to be. Well, let's check the battery. Potential difference across the battery is still 9 volts. This is a 9 volt battery. It supplies a potential difference of 9 volts. Each bulb, let's check, bulb A. Now it's 3. So that 9 now has been split by 3 bulbs. So they split the potential difference equally. So they get 3 volts each. Okay, so bulb B is 3 volts and bulb C is 3 volts. If we measure across the 3, add them up, the total is 9 volts. So you get the idea. All right, I'm going back to my screen now, to my OneNote screen, pausing the video. Okay, guys, so the potential difference across the cell I got was 9 volts. Now, I presume you got the same unless you change some of the settings, 9 volts. Potential difference across each bulb individually, well, bulb A equaled 4.5 volts and bulb B, sorry, spell it right, bulb B equals 4.5 volts. So each one split the potential difference, 4.5 volts each. Potential difference across both bulbs together was 9 volts. Okay, now how do we draw this? How do we draw the voltmeter? Okay, well, I'm drawing a circuit here with one cell. And you notice this time I don't put the voltmeter into the circuit. I'm not putting the voltmeter into the circuit. I've got my two bulbs like this. Why are you doing that? Okay, there's bulb A. There's bulb B. Now, how I show potential difference being measured across a device is like this. Got a wire. It's a separate little mini circuit, like this. So the voltmeter, you show it connected to both sides of the device. So that's how we would show a voltmeter connected. What I want you to do is I want you to pause the video and show a voltmeter connected across each bulb. So each bulb, connect a voltmeter across to measure the voltage. So I want you to draw what I have here, and then I want you to put in a voltmeter for each bulb. Pause the video and do it now. Okay, this is what you should have, a voltmeter across each bulb. So you've got a little mini circuit with a voltmeter across bulb A, and you've got a little mini circuit with a voltmeter across bulb B. So you'd have 3 voltmeters in order to do this. Okay, if I wanted to connect a voltmeter across both, then I would have a voltmeter connected across both, like this. Okay. Now I'm talking a lot about voltmeters and ammeters, but really, and years ago there was a separate things called voltmeters and ammeters. But really, nowadays modern electricians, mechanics, and most scientists who are measuring voltage and potential difference, they don't use separate ammeters and voltmeters anymore. They use one of these, and this here is what we call a multimeter. So multi just means many, so we can use this for many different things. So it's got this little dial on the front. I'm not sure if you can see that you can twist around, and you can set this to whether you want it to be reading voltage, current, potential difference, current, resistance, and a hell of a lot more. There's an awful lot of stuff on here that I don't even know what it is, to be honest. If you were to train as an electrician or a mechanic, then you would have to learn what a lot more of that stuff is. I just know the basics that we need to know for school. So this is what we call a multimeter. As you can see here, it's got little ports on this side that you can stick your wires into. And then you'd either set it up as an ammeter by putting it into the socket like a device to connect it into the socket, or you would set it up as a voltmeter by connecting it across the device, and then you would set it to read either current or amps. So that is a multimeter, just so you're aware that nowadays there used to be things which were separate ammeters and voltmeters, really old technology, but new technology we can use digital multimeter. Okay, great. It's time to do some practice questions. All right, so I have some questions for you to practice. So I want you to pause the video and I want you to have a go at these questions, please. Sorry, just going to fix up something here. Just give me 1 second. Okay, so I want you to pause the video and I want you to try to do these 9 questions for me now, please. Okay, so you should only be watching the video if you have done these questions. Hopefully they're pretty straightforward if you've been paying attention. So you have to draw a circuit with 2 cells and 2 bulbs. So here is my 2 cells. So I've got the short terminal and long terminal, and that's the first battery connected to the long terminal, the long terminal and the short terminal, positive and negative of the second battery, or the second cell, I should say. I'm calling them batteries. All right, so we've got 2 cells. Here they are. And I've got my wires and I've got 2 bulbs. So here's bulb 1, here's bulb 2, and connect them back around. So that's what you should have got. Well done. If you drew that, good. Correct it. Add a voltmeter to each bulb. So this is what you should have had. Here is bulb A, and we've got a voltmeter connected across bulb A. That's how we describe that. And here is a voltmeter connected across bulb B. So well done if you got that. So you should have those 2. Good job. Add a switch. Okay, so hopefully you did this in pencil like I asked you to when drawing circuits, and then it's easy to add this. So a switch, you would stick 2 terminals here like this, and the switch doesn't say where it's open or closed. I'm going to draw it closed. So there is the switch closed. Draw a circuit with a resistor, a motor, and a switch. A resistor, a motor, and a switch. Okay, it doesn't say anything about a cell. So I'm presuming you need a cell. I'm going to have to fix that. I'm going to add that so that it's right for the next time. With a cell, a resistor, a motor, and a switch. Right, so here's a cell. Because remember, a circuit won't do anything without a cell. It's got no power then. So what do I need to add in? I need a resistor. So I'm going to stick the resistor here. It doesn't really matter what order you put them in. A motor. So I've got a motor here. And I've got a switch. So I'll put the switch over here like this. I'm going to draw it closed and connect it up like that. Well done if you got that right. If you didn't have the battery, that's fair enough because I didn't ask you to draw a battery, but know that the cell won't do anything unless you put the circuit won't do anything unless you put the cell in. So it's probably a good idea to add a cell now, even if you didn't. I know that's kind of my fault. Right, on a socket, show how you would measure the current in the socket. All right, so if we want to measure current, then we're going to have to make another place. So we're going to have to make down here, maybe, we're going to have to stick our ammeter, A. We have to put our ammeter into the socket if we want to measure the current. Okay, so this here is to measure current. Well done, if you got that right. If you put an ammeter in, that's great. If another device were added to the socket, how would the current change? Well, if you put another device in, so there's already a resistor and a motor, the switch doesn't really affect the current, it just turns it on and off. But if I was to put in another thing, like say another bulb, then it would reduce the current. Okay, so more resistance means less current. So it would reduce the current or lower the current or make the current smaller, something like that, along those lines. Reduce the current. Sorry, that's, yeah, that there is for this question here. So if another device were added to the socket, how would the current change? It would reduce the current. Well done, you got that right. Explain your answer. So you have to explain your answer. So what would we say? Resistance slows down the flow of electrons. Or you could say a device adds resistance. Device adds resistance to the socket, and the resistance slows down the flow of electrons. So every device, well, not every device, like a switch doesn't, because that just turns the socket on or off, but any of the devices which transfer energy, so the ones we learned about in the last video, like the motor, the heater, a motor, a resistor, a heater, a bulb, an LED, all of those would provide a resistance to the socket, and that would slow down the flow of electrons. So hopefully you said something like that. Slow down the flow of electrons, and why? Well, they add a resistance which slows down the flow of electrons. On the socket, show how you would measure the potential difference across the motor. Okay, so potential difference across the motor. I'm actually going to need to move this a little bit to make space. So I'm just going to move that over there. And I'm going to draw in my voltmeter. Now, how do I draw my voltmeter? Well, I'm measuring it across the motor. So I've got my wire, my little mini loop, basically, a little mini socket around the motor with the voltmeter inside like that. Okay, so that is how I would measure the voltage. Well done. If you got that right, good job. Name 3 devices and how they transfer energy to the surroundings. So this is from the previous video. So we have a bulb. Bulbs or lights transfer energy by what we call wave transfer. So well done if you said that. If you mentioned bulb and wave transfer, well done, because light is a form of wave transfer. All right, if you didn't know that, you didn't really get what the question was getting at, maybe now that I've told you that one, you can do the 2 other ones. So pause the video if you don't already have them done and do them now. All right, so the other one, another one is the motor, and it transfers energy by mechanical working. So the motor spins around and can transfer energy to the surroundings by mechanical working. So if the motor is connected to, say, a gear, then that gear can move other gears. If it's connected to a paddle could start moving water or something like that. So again, transferred by mechanical working. The last one then was a resistor. How does a resistor transfer energy to the surroundings? Transfers by heating. So it gets hot and it transfers energy by heating. Well done, if you got that right. That's it for today, guys. We have learned how to measure current and resistance. Resistance, current and potential difference in a socket. We've learned how to build a socket and add an ammeter to measure current. We've learned that the current doesn't change anywhere in the socket unless you change either the battery or you add in extra resistance. Then the current is the same everywhere in the socket. we've learned that the voltmeter is connected across a device in the circuit, and that the voltmeter is different in different parts of the circuit across the battery. It's usually the voltage of the battery. So if it's a 9-volt battery, then potential difference across the battery is 9 volts. If it's a 12-volt battery, it will be 12. If it's a 6-volt battery, it will be 6. And then across the other devices that are transferring energy, we notice that the voltage will get split, or our potential difference will get split across the devices. So for example, if we have 2 bulbs, then the potential difference across the battery was 9 volts, and potential difference across each bulb is 4.5 each. So if you measure it across both bulbs, it will be the 9 volts, the same as the potential difference that was given out by the battery is being transferred to the surroundings by the bulbs. But each one gets half of that potential difference. All right, that's pretty much it. So guys, if you found the video helpful and you found it easy enough to understand, please do leave a like. It helps other people to find the video. It helps the channel. And if you found that particularly interesting, or if you've done this topic before and you found it hard and this has made it easier, please do leave a comment which explains why you find it easier, because it might help other people to stop and have a look. And again, it just helps out the channel. So thanks guys, and I'll see you in the next video.